Hi everyone, thank you all for joining today's webinar, How AI is Changing Defect Detection. I'm Kirti from Zuci Systems. I'm going to be your moderator for today's session. Before we begin, I'd like to cover a few housekeeping announcements for the audience. This is a live webinar and is being recorded. We'll be able to share a link with you in 24 hours once the event is complete. We invite comments and questions from the attendees. If anytime during the webinar you think of any questions for the speaker, you can type in the Q&A box. We'll be able to hold it for discussion at the end of the event. As a part of agenda today, first we'll discuss the evolution of defects over the years and the need for defect detection, which is the very essence of software testing, followed by the role of artificial intelligence in software testing arena today, where our presenter will walk you through an interesting example of an organization who has been an early adopter of AI in testing, followed by the importance of data in artificial intelligence and how it can help bring better AI outcomes. Finally, we'll finish it off with a question: is it completely artificial yet or augmented? Now, I'll introduce you the presenter for today's session, Vasudevan Swaminathan. He is the President and Chief Consultant at Zuci Systems. I'm going to hand the floor over to you, Vasu. Vasu, it's all yours.
Hey, thank you, Kirti. First of all, welcome all the attendees for this session today. Thanks for taking the time to join us today. I know that this is a very interesting topic, and there is a lot of hype and hoopla surrounding this in general. Whether you do a Google search or anywhere, people talk about artificial intelligence and software testing, software development, how artificial intelligence is going to take over, and all that actually. So I just want to set some basic ground lines, or I just wanted to give some basic clarifications before we move forward as to what this webinar wants to address. We are not going to talk about any particular genre with respect to artificial intelligence. What I mean by that is we are not going to pick a test automation, or we are not going to talk about how UI automation can be made better through artificial intelligence or anything of that sort. We want to set the ground rules for using artificial intelligence in software testing, what it demands, and to provide the software testing community or the attendees here with clarity on what it means in order to embrace artificial intelligence to apply it in software testing. What is that you will need? And that's what this webinar intends to address by citing examples of other organizations that are outside the realm of software testing, or rather software itself, and how they are applying artificial intelligence today. That's one. Number two, we are not going to go into cognitive automation or robotic process automation, talk about bots and things like that. That's not the agenda here. The domain itself per se, robotic process automation, in my opinion, is not intelligent actually. So we are not going to get into that. We are going to specifically focus on examples with respect to software testing and how artificial intelligence can influence, or how it can be a game changer in specific areas of software testing. So without taking a particular area in general, we are going to discuss an introduction to artificial intelligence and allied systems like data sciences, machine learning, and talk about where these entities or where these areas are making a difference in the software testing world today. So it's more of a primer to how you can apply artificial intelligence to software testing. And when I say primer, it gives you an indication of what different tools to use, what the ground reality is, what it demands, and things like that. So with that being said, as Kirti said, please go ahead and shoot any questions that you have. In the meantime, in the chat window, we will try and address it as much as we can. Let's move ahead, Kirti. Let's go to the first slide. And we will start off with the cost of defects basically, and that is something which is not new to most of you here. But I just wanted to start off with this because the intention of software testing, whether we agree or not, is to produce better quality. And what it means to produce better quality is to make sure that or one of the major areas that it does in the process of improving quality or producing better quality is to eliminate defects early in the cycle. And for the last 20-25 years, no matter what software engineering methodology you have used, whether you have been a waterfall model tester or a waterfall model engineer, or you have been in agile, or you have used behavior driven testing, or you have done test driven development, or you are into continuous integration, continuous delivery, the model doesn't matter. Whatever it is, the engineering discipline has focused on one major thing, which is to see that customers don't find defects in production and they can be eliminated early, which I believe all of us can agree upon. So that's a very important area, and that will continue to be an important area even 50 years from now. So I thought it will be important to start off this presentation with that particular aspect, so that we see how artificial intelligence can connect back to this and make defect detection better and defect prediction better, actually. So I'm just setting the ground rule here. So as we all know, any defect that is found in the same phase, a defect that can be found and identified, or rather, found and fixed in the same phase, costs much lesser than the same defect being identified in another phase. That's the premise here. And you can take it in any form that you want. For example, if there is a design defect that is being found in production, then the cost of finding it is, or fixing it is, 30 times more than the defect actually being found in the same phase, which is design. And it applies to other phases also. You can miss out on a requirement defect in the requirement phase itself, and you can actually move into other phases where, if the same requirement defect is being found, the cost of fixing it is much higher, actually. So I believe when we say the cost of fixing it, what we mean is the number of resources we have to expend on that, the number of people who will be developing or fixing it again, the number of people who will be testing it again, whether it is regression, retesting, the cost to fix it from a software development standpoint, change to the architecture, all of that is going to cost us in terms of people, in terms of days, schedule, everything. And that's what that's what actually triggers the need for defect detection early in the cycle, right? So the objective is to make sure that defects are found in the same phase, so that we don't have to spend money and time in fixing it at a later point of time. With that premise being said, we will also take a look at some of the examples that we have seen over time in terms of how defects have been leaked into production and what kind of impact they have had, before we discuss artificial intelligence and how it can help. Some of the defects, if you look at it chronologically, some of the key defects that we have tried to capture or to present to the attendees here is the first bug that was found in 1947. It was literally a bug that was caught between a processing machine and a compiler, basically. And the notes of that being captured is still available in the museum in Virginia. So that probably triggered the name bug itself. I'm not sure. But 1947 is when an actual bug was found, when the processing was happening between machines. And from there on, if you look at it, there have been a lot of defects that have leaked into production, and which have caused a havoc, I should say, including the Mariner 1 spacecraft in 1962, the Morris worm in 1988, the Heathrow Terminal 5 opening in 2008, which is one of the biggest issues that have been identified as a software fault in history, which impacted the baggage handling systems. And recently, again earlier this year, in 2019, we saw that defects were causing a lot of flights to be cancelled and a lot of flights to be delayed due to a software issue and things like that. Um, why is this slide important? Why are we trying to show this? Because software defects will continue to be there. And as we see in a lot of QA forums, the aphorism goes like this: the objective of software testing is to find defects. It's not to guarantee the absence of defects. It's to guarantee the presence of defects, basically. So defects will continue to be there, and with more and more efficiency being put in from an engineering standpoint, maybe they will get reduced. But we are not going to get to a stage where we saw absolutely zero defects or anything like that within the world of software. But it will be very interesting to see how artificial intelligence will play a role in order to make better predictions and things like that, since people are moving into better prediction accuracy, pattern accuracy, and things like that. So we will get there towards the end of this webinar. But we just wanted to present this slide to give you a fair idea of defects still continue to create an impact, and there are specific ones that can actually lead to a lot of monetary and time losses, basically. So let's move ahead and talk a little bit more about defects before we move into the other parts of this webinar. As much as we talk about cost of defects, it is important to understand how the evolution of testing has happened in order to address defects from cropping up. So, some of you here in this attendee list would have been testing for a long, long time now, maybe since the early 90s or the late 90s. At least that's when I started towards the late 90s. And we all know that, in the traditional world, it was a waterfall model where a lot of manual testing was happening, and waterfall being a phased approach. It starts off with requirements and then design, where you do high level design, low level design. Then you get into development, and then testing comes in. So naturally, testing comes towards the end, just before maintenance. So any defect that has been missed in the earlier phases will have to be found in testing. But again, there is a very high chance that you may not have enough time, you may not have the opportunity to find everything, given that testing was itself allotted very little time. And that was the case between 1980 to 1990. And as some of us know, towards the end of 90s, early 2000, automation got introduced. I'm sure some of us here would have had the opportunity to work with tools like Windrunner and Borland Silk Test, which was Borland at that point of time. More of record and playback, trying to mimic the user's actions, making sure that instead of the user or the manual tester running tests repeatedly, if there is a way to mimic their actions in a record and playback fashion, tools were introduced to do that actually, and screens were captured, fields were being fed with information, and tests were run repeatedly to make sure that the manual tester need not do it again and again. And that was the early 2000, late 90s time frame when automation tools came into existence. Naturally, late 2000s or early 2000, around 2003, 2004, a more agile approach to software development emerged, and it continues to stay there today. A lot of variants of agile have been introduced today, but post the agile manifesto being published in 99, during the early 2003, 2002, 2004 timeframe, a lot of projects started moving into the agile fashion, or agile mode, I should say. And automation on agile projects continued to be a challenge, where sprint automation was being done. People started doing in sprint 1 or sprint 2, while they started writing manual test cases in the first sprint and things like that. And with the introduction of Selenium, around the early 2000, automation became a huge area of opportunity for many people, and it also started bringing in efficiency. In fact, it will be very interesting to note that all that we do in robotic process automation today is all a step from software testing. If you actually look at it, whether the bots run it today, whether you schedule and run the bots and all of that, capturing screens, trying to reduce manual effort, all of that actually started with automation testing. So robotic process automation, in my opinion at least, is just an enhancement over software testing, though it is used in a different form today. But it is very interesting to see that software testing has paved the way for robotic automation today. So going back, Selenium changed the landscape for automation, and there has been a lot of changes between 2000 and 2010 in terms of automation itself. And that naturally led to DevOps, continuous testing, continuous integration, and everything. And I think, and that's the world we live in today, actually, where we talk more about DevOps, doing spinning machines, different environments, using automation to do that, and things like that, or what people refer to as complete or end-to-end automation and things like that, actually. But while we continue to exist in the world, there has been a sudden surge in terms of using, artificial intelligence and, systems like data sciences, or I would call it as allied areas of artificial intelligence, like data sciences, machine learning, which people seem to be a huge game changer for the world of software and software testing, together. So people are talking about how machine learning can make a difference, and with companies like Facebook and Amazon continuously trying to show that they are able to pattern, or they are able to predict our behavior based on the patterns that we exhibit and things like that. There has been a huge hype surrounding how automation or how software testing rather can actually make people's life different and easier with the application of artificial intelligence and allied tools like data sciences, machine learning, and things like that. So The focus of this webinar is to talk about that and provide more clarity on what exactly is artificial intelligence and allied systems like data sciences doing for software testing, and what is that they're relying on. That's what we are going to talk about as we move forward. But I just wanted to present this viewpoint in terms of testing has tremendously changed over the years, and with artificial intelligence and everything coming in, it's going to be very, very different actually. So let's move forward and see what artificial intelligence is doing today in the world of software testing. It's a very important thing to note that artificial intelligence in testing is not new, but artificial intelligence in software testing is new. So we have had the opportunity. So for example, even the attendees, if you go ahead and do a Google search saying artificial intelligence in testing, you might get a lot more articles on manufacturing and other industries where artificial intelligence is used in testing as opposed to artificial intelligence in software testing, basically. So we tried to capture some examples of where companies are using this today. For example, artificial intelligence is used heavily in manufacturing lines of phones. And there are companies that are in China or in the Silicon Valley in other places where they try to capture a snapshot of a defect that happens in production. Let's say there is a Motorola phone manufacturing line, and there is a small metal piece within the phone that is slightly bent or something like that, which ideally should not be the case, as it could impact the user in terms of when they use the phone, it could impact the user basically. So what's happening today is companies are trying to create cloud-based databases where they can capture snapshots of such minor trivial issues which can have extremely high impact for users when they use the phone. So while they might sound very trivial in a manufacturing or a production line. So what companies are doing today is they're trying to take snapshots of this as the production line keeps running. And if there is an anomaly that is being detected, then it is being stored to a cloud database. And then when the actual production line runs, I mean, in testing, we call it as, in software testing, we call it as expected result versus actual result. So similarly, in the production line, which is the actual result, if there is an anomaly or an observation that is being found, immediately that observation is being compared with the cloud database where the snapshot of the expected result is being stored, and those are being compared, and the artificial intelligence system basically takes that phone out of the production line and says this is not what it is, this is not meeting the actual expected result, so this is not part of production. And this is done using artificial intelligence, and there are a lot of companies that are using Python, R, and other technologies to do this basically. So it is important to understand that while software testing is new to artificial intelligence, testing itself is not new. And similarly, if you look at it, artificial intelligence powered system called WiseEye has been introduced by the Hong Kong Polytechnic University, specifically for the textile industry, where the naked human eye won't be able to find quality issues in a material like textile. While there could be a, let's say, the material is torn or something like that, it is easy to, see that and say that there is a defect. But quality issues or subtle issues with respect to, material quality and things like that is very difficult to capture. But interestingly, taking help from people who are actually part of the textile production line, the Hong Kong Polytechnic University has introduced an artificial intelligence system that can be applied in the textile testing arena, where the system can actually detect better quality or low quality defects basically, which are difficult for the human eye to catch. And it has been working well for them. And there are claims that defects have been reduced by 7 to 10% within the textile production line or textile manufacturing line. And manual inspection time has been reduced by up to 80%. And beyond that, if you take car manufacturing like a Toyota, Honda, Audi, everybody has started embracing artificial intelligence, and not today. It's been there for a while now, and they have tried to use cognitive intelligence in order to do visual inspection of a particular spare part or a particular piece that goes into the car and things like that. So the point that we are trying to arrive at here is software testing and artificial intelligence can be a new combination, but artificial intelligence in testing itself is not new. It's been happening for many years now, and there are a number of case studies and articles where you can refer to each one of this and look at how people are using it in the manufacturing industry basically. So as I said earlier, the processes First, you'll have to collect data and look at what kind of failures are happening, look at any anomalies, observations, and everything, and then create patterns out of it, and then train the model and make sure that the model is able to capture if something goes wrong in a production line. So this has resulted in early detection of defects, and as we said earlier, defects have been reduced by 7 to 10%, and inspection time has come down considerably from a manual standpoint. And as we move on from here, you might be interested to know there is a very, very important organization in the world that has been using artificial intelligence in software testing itself, but their process is what is extremely important for us to note. So let's move ahead and see which organization that is and what they're using in software testing using artificial intelligence. So, as we all know, the National Aeronautics and Space Organization, which is NASA in the US, they have been one of the early adopters of artificial intelligence in testing, particularly in software testing, I should say. And for them, as you know, they launch a number of satellites every year, to the moon and to other planets and everything. And they use a number of components as they do this. So it is not that the satellite gets launched without no effort. I mean, there are a number of components that go into building the satellite, and each one of them would require testing apparently. So what that means is, how is NASA using artificial intelligence? How are they trying to use artificial intelligence in the different components to check it from a software standpoint before the satellite actually gets built? So the process that they follow would be extremely important to note here, because that would be the process that any software testing system or any software would need if somebody were to apply artificial intelligence on in testing that software. So if you look at it, NASA starts off with a data collection phase, and that's a very important phase. So they collect over 40,000 failure records that has happened when a software gets built or when a satellite gets built, within the different components surrounding the satellite. This includes operational failure and any other non-software failures, software failures, and everything. They collect a lot of failure records. 40,000 is just a number that could be very specific to a component or very specific to a satellite that was built in the earlier days, but that's just a number. But what's very important to note is data collection. And that's the fundamental premise for applying artificial intelligence. So they collect a lot of failure records basically, and then try to do a statistical analysis on them. Now, this could be a team of data scientists who are looking at it to see what different types of failure records are we seeing here, what behavior they exhibit, and what kind of identification techniques do we need to use in order to identify different types of failures and things like that. And once they do the statistical analysis, they do a classification, and the terms that you see here are software engineering terms. These are not NASA specific terms, but Bohr bugs, Mandel bugs, aging related, all of this is general software engineering related terms actually. So if you go ahead and make a search about Bohr bugs, you can see what they are. So it's a generic term. So typically, Bohr bugs are the ones that are easiest to find, and it is easy to identify the cause of failure. Mandel bugs are one which may happen once in a while. It's happening, but difficult to isolate, and you need to do a lot of recreation in terms of, or you need to do a lot of retesting in order to recreate that issue and things like that. Again, aging related is more in terms of what happens when a component has been in place for a long time. With aging, wear and tear and things like that, it could operate, or it could behave differently, causing a failure and things like that. So post the statistical analysis phase, they get into a classification phase where they try to classify each one of them. And then what they do is they try to use machine learning. Machine learning is one of the allied areas of artificial intelligence. So when we talk about artificial intelligence, the immediate image that comes to our mind is a robot walking, carrying something and things like that. That's not the case always. Artificial intelligence typically refers to a lot of other things, but the two important categories being data sciences and machine learning, which are sub areas or allied areas of artificial intelligence. So what they do is, once they do the classification, they make sure that the machine learning model, a supervised machine learning model, is created with all this failure data, and the data scientists try to make sure that this model actually is being fed with all this failure data and things like that, so that it can identify defects with accurate prediction, and it is able to actually bring in more efficiency to the defect detection process itself. Now, this is a very important use case, or this is a very important learning that we need to take if we are looking to apply artificial intelligence in software testing. And the most important learning from this slide that I want to point out is data. Data is very, very critical in order to have a efficient, effective artificial intelligence system for finding defects or for anything that you want to do. If there is no data, artificial intelligence systems can be very, very biased, and they won't be able to get to the level of prediction that you want to get from them. So in order to ensure that an artificial intelligence system gives you better prediction, it is important to make sure that the right data is being fed to that. So as we move forward in this webinar, let's look at what kind of data are we looking at from a software standpoint. If we were to apply artificial intelligence in software testing, what kind of data sources are we talking about and things like that. So let's move ahead and see the importance of data and what kind of data are we talking about. As we said earlier, the data makes the difference. There are a number of experts within the artificial intelligence space who talk about data. You can, I mean, if you are interested, you can read about, a lot of papers, a lot of things about, how data is the key game changer to artificial intelligence. You generally Google, you will find, everything. In fact, there is an artificial intelligence needs of hierarchy that is being published that's very similar to Abraham Maslow's needs of hierarchy for human beings, where he talks about from the basic needs to physiological needs, psychological needs, and things like that. Similarly, artificial intelligence has a needs of hierarchy. It starts off with data and everything before you even apply it. Without the basic things being taken care of, your physiological needs or psychological needs are not going to make a difference actually. So the data is where most of the importance lies actually. So if you were to use any artificial intelligence system like data sciences or machine learning to make betterment in your test cases, to generate better test cases, or to optimize test cases, or even to do test automation, the most important thing is, what data are we talking about here? What kind of data should I look at? What kind of past test cases should I refer to? How much of them do I have? Are these really useful to be fed to a machine learning system in order to get better, accuracy, prediction, and things like that? And it applies to, test automation or anything for that matter. So what all experts say basically is, underlying machine learning and artificial intelligence efforts will fail if no quality data is fed to the machine learning engine. This is extremely important, and this is not a software tester's job. So one of the main reasons we wanted to, we wanted to highlight in this webinar is, software testers' role is not to create machine learning models, and they won't be able to do that, but they can be an active participant in creating a machine learning model, sitting together with data scientists and others actually. But the data itself will make a game changer. The data will be the game changer that will make the difference actually. So in terms of what is that we need to look at, what is that software testers will have to look at in terms of data? Where do you collect data? How do you classify and feed the data? And how do you build the right data model in order to do a defect prediction, or in order to make betterment in a defect detection, let's say. So we will talk about that as we move on. Let's move ahead. Where is the source of our data today? Now, we live in a very digital world. We are talking about digital transformation. We are talking about digital experience. We are talking about exceptional customer experience. User experience and customer experience are the two words we hear every single day, no matter of what sphere of life we are in. Whether we are traveling in a flight, we talk about a pilot or an air hostess making a difference to a user. Actually, it could be celebrating their birthday on the flight by announcing over the speaker, so that everybody looks at the passenger and the passenger feels so proud, and people call it as enhancing customer experience. That's for a flight travel. Now the same when it comes to mobile, when you use a mobile phone, you want to make sure that you get an Alexa, or let's say you get a Siri that can bring you an exceptional experience. Kids are talking to Siri today, and they say that Siri is their best friend. It provides all the information, it provides all the answers and everything, and that's all about making customer experience better. And how do you make this customer experience better? Because when you look at artificial intelligence systems, it was not, it is still not there yet. In fact, Microsoft tried to create two different bots, which they put on Twitter actually, but they faced a massive failure. They actually couldn't succeed because the bot was getting very, very influenced, and it was giving all the wrong answers. In fact, it went to a point where, it became quite controversial because, the bot started making a bit of racist remarks and things like that. Microsoft's one that I'm talking about. So they even pulled it back actually. So exceptional customer experience comes from learning, and learning comes from the data. And what kind of data are we talking about here? So we are looking at application logs, database logs, test execution logs, performance logs, production logs, and everything actually. So some of the attendees who are part of this webinar today, you might actually relate to what I'm saying. If you have if you had worked in a client server environment back in the late 90s, early 2000, because we didn't have so much of cloud then actually. If you remember, in client server environments like a Visual Basic Oracle environment, if you have worked, most of the times developers used logs for debugging. The first source of debugging starts with the log, and log is where developers used to put a lot of information. And they used to say if something goes wrong, they will say go and check the log and see what the message is. Let's get started from there. Now 20 years later, we are still looking at artificial intelligence to read logs, identify patterns from logs so that customer experience can get better. And what are these logs? Well, these are the sources of data basically. And what are these? These are application logs, database logs, test logs, and everything, production logs and everything. So for a DevOps team, a production log could give a different kind of insight into why something is happening. For a database team, the database log could give a different kind of information. But if you collate all of this and provide it to a data scientist team, then it leads to better customer experience, right? So what happens once we get these logs? We need to analyze the data. That's why I referred to the NASA slide actually. You need to analyze the data, you need to cleanse it, you need to review the data before you actually feed it to a supervised machine learning model that can actually build using this data in order to provide with better defect detection, prediction, accuracy, and things like that. So I just wanted to highlight the importance of data here. Let's move forward and see what data can do, and what difference it can make to software testing from an artificial intelligence standpoint. A little bit more on data. As we said, better data, better AI outcomes. We are spending some time on this because this is extremely important. Most of the world thinks that software testers can use artificial intelligence directly. That's not the case. They can be contributors towards data. They can be data contributors, but they are not builders of the model itself. So the reason why we are once again stressing or emphasizing on this is artificial intelligence can be easily influenced. It can be very, very biased. And that bias comes from the data that you're feeding to it, actually. If you feed the wrong data, you're going to get wrong predictions. And, we have seen that in many cases. Let's say you go and buy something on Amazon today. Maybe for 80% of the time, it makes the right recommendation saying that, people who bought this also bought this. But sometimes you wonder why it is recommending something that is totally irrelevant to what you purchased earlier. So those are moments where we think, why is this recommendation being done? That's happening because some user who has purchased it earlier has done some other purchase, and the machine actually, the real-time engine that Amazon uses, looked at that user's data and it consumed it to make for some betterment, and it thought it's making the right recommendation. So when you're buying a trouser, and if it makes a recommendation of a shirt, that makes sense. But when you're making when you're purchasing a trouser and it makes a recommendation of a raincoat or a attire that needs to be worn, that you can wear when you go for a hiking or something, or a skiing or something, that's kind of irrelevant. Though it could be part of the category called attire, it is not in line with what you're looking at. And those things happen to us time and again. I'm sure you will all agree with me there. So that recommendation happens because somebody somewhere purchased it, and the real-time engine, the machine learning engine, consumes the data, and and it thinks that users actually buy it, and then it makes the recommendation to you. So that's the most important part of what we want to talk about. When you train the data, when you train the machine learning algorithm, it is important that you feed it with the right kind of data, and then you need to evaluate it, make changes and things like that in order to get better prediction. And the input data needs to be very, very clean. It needs to be with a lot of integrity so that predictions do not go wrong. Basically, the model needs to give the right predictions, and the model needs to be trained with continuous data in order to get better insights and accurate predictions and all of that actually. So this is a very important part of artificial intelligence, or this is the fundamental premise on which artificial intelligence works. Without the right set of data, there is no point in building an artificial intelligence system. Let's take it forward from here and see how this applies to software testing. So for a moment, we spoke about data. Where is data coming from? We saw that we spoke about application logs, performance logs, production logs, test logs, and everything actually. So how do you cohesively build this? If you actually look at it, if I'm an organization today that wants to apply artificial intelligence within the software testing arena, how do we go about this? Where do we get started? What's my source? What can I do about this? That's a question that constantly comes up in our mind. While we are all excited to use artificial intelligence, we are more interested in terms of where do we get started? What do we do with this basically? So the word artificial intelligence can be looked upon a little differently, as augmented intelligence. Typically, augmented intelligence means that you bring in systems to replace humans, but artificial intelligence means that you bring in systems that can replace humans. But augmented intelligence means that you take help from humans in order to make your artificial intelligence systems better, which means that they coexist, they complement each other. In fact, there is a very interesting book about how Gary Kasparov, the world famous chess grandmaster, was bit by the supercomputer back in the late 90s. And there is a book that Gary Kasparov has written about it, where he talks about augmented intelligence as the way forward for artificial intelligence systems or missions. Actually, he says humans who are subject matter experts, who are quite experienced, quite used to the ways of a particular software or a particular product, can actually build better artificial intelligence systems with their knowledge. And we always know that humanity has found computers, humanity has found artificial intelligence, and humanity is the brain behind everything. So artificial intelligence are not going to replace humans, or rather they can, but artificial intelligence systems can actually build better if humans can actually work with them and if they can complement. So to that effect, let's consider augmented intelligence, where let's say QA teams, for example, can provide information about past test cases, defect history, production logs, and all of this. Subject matter experts like business analysts or banking experts in a particular company can provide a lot of information to the data sciences team or to the artificial intelligence team that is building the model, so that the data sciences team can analyze it and they can cleanse the data, ensure there is integrity, ensure that the data is useful in order to train the machine learning model. And that could actually become a better artificial intelligence system in terms of getting better prediction and things like that. So it is important to understand two things from this slide. Number one, it makes sense to use in-house teams who understand your data and the context in order to build a machine learning model and to train and continuously get better insights out of it. Number two, external tools that are sold saying that we use artificial intelligence for test automation or defect detection can be helpful only if they can be customized to your context and your needs. So if you buy a system today and if you think overnight you will get better defect detection or better automation with artificial intelligence, I don't think that's going to happen. If you want to make that happen, there is considerable time you need to spend from your side in order to tweak or customize the system according to your context. Otherwise, it's not going to help you directly, overnight. It's going to take time. So it's extremely important to understand that manual QA testers or automation testers today can make a difference to the artificial intelligence system that you want to build, because they know what kind of defects customers are finding. They will understand the functional defects that are critical to be fed to the machine learning system, and their inputs can actually build a very, very effective artificial intelligence system that can work with very, very limited bias, and it can help you in getting to better insights and better accuracy prediction and things like that. So it's important to understand that augmented intelligence could be a great way of building better artificial intelligence system. Let's move forward and see how this can be applied to an example. Today at Zuci Systems, what we do is we, in fact, try and do augmented intelligence systems for our customers today. So what I mean by that is, today we don't do a lot of automation based. We don't apply artificial intelligence in test automation and things like that. But what we are doing today is we are trying to make life easy for teams like QA, developers, and DevOps teams that are working on production issues. For example, today we have built a shopping cart of test cases for any production issue that a customer finds. Now, again, this is not a by the book solution, or this is not like buy from the shelf kind of a solution. We have worked with customers for some time, let's say 12 months to 18 months time, understood what kind of defects they are finding in production, understand what kind of test cases they have in the test management tool, and then use that in order to make a recommendation of test cases or a shopping cart of test cases to say, when a production issue happens, we look at it, and then instead of the manual tester going to the test management suite, trying to identify thousands of test cases to run to make sure that the production issue goes fine back, or it is fixed and tested well before it goes back into production, we actually try to do it for the manual tester and for the other team members actually. Why are we doing this today? The simple reason is because when a production issue happens, the first thing is there is extreme pressure on all teams. Number one, the issue needs to either go as a hotfix or as a patch within the next 48 to 72 hours, let's say. So if somebody were to work on this, then the QA needs to test. So developers, as they fix it, QA needs to test this actually. So the developer is also strapped for time, and QA particularly is strapped for time. While developers can make a fix, the impact of that fix, which can lead to regression issues, is something only QA can identify. So QA has limited time. Let's say you are doing this on 3 different browsers, 2 different devices, and 5 different operating systems. You are already bringing in 5 into 3 into 2, which is like 30 combinations. And assume that you have at least 200 test cases to run. 30 into 200 is 600 test cases. Do you have the time to complete the 600 test cases? I'm talking about a very, very base minimal pack here. Now, do you have the time to do the 600 test cases in about 48 to 72 hours time? Maybe not. So what do QA teams do in terms of quality assurance? Can they assure quality in this case? What can they do? They might probably say, I did about 300 cases, but I'm not sure how much of coverage I have given here. In order to overcome this, what we have done is we have tried to create a shopping cart of test cases for a production issue and say, in order to test this production issues, take these test cases and run them. And this can be set in your continuous integration environment or whatever, once you make sure that you're fine with this. So we make that recommendation, or we create the shopping cart of test cases and give it to QA, in fact, to developers and to DevOps teams in terms of use these test cases for the production issue. They should provide you with maximum coverage that you need. And this recommendation we are making because of patterns that we are seeing in test cases, patterns that we are seeing in production issues and things like that. So based on that, we make this recommendation, and that recommendation helps actually, so that QA teams have the guarantee that they are able to say that they need so and so time. Generally, for production issue, QA struggles to say how much time they will need to test it. But by providing a shopping cart of test cases, we help them in saying, well, I will need at least 3 days to complete this, but I will be able to give you 90% coverage because I know that I've got the right set of test cases. And it saves the time for them to go and search, go and scout for test cases for that issue. Instead, the artificial intelligence or the augmented intelligence system that we have built makes that recommendation that QAs and other team members can take, use it, and then be confident that they would be able to complete the execution of test cases in the given time. They will be able to produce effort estimates for the time to execute the test cases, and eventually they are able to say that I'll be able to provide you with so much of coverage. And that gives a huge confidence to managers, supervisors, engineering leaders, and to the customer also, because you can release it to the customer and say, I've tested all of this, I'm pretty sure you will not find anything major when the production fix goes back inside. So that's something we are doing today, and we strongly believe that that's a great start for artificial intelligence, and that's an area where artificial intelligence is or can indeed make a difference to the defect detection process itself, basically. And as you can see, this relies on past data. We are looking at past history of test cases, logs. We are looking at past issues that have cropped up in production. Are there similar issues? What did we do at that point of time? What test cases did we use then? Was that useful? Can we go ahead and take those test cases? Okay, then what additional test cases can we add and things like that. So that's an area where we are making a difference to defect detection using artificial intelligence, or rather augmented intelligence, taking help from developers, QAs, and everybody actually. So I would like to leave the attendees with this thought that it's a great initiative to get started with artificial intelligence for defect detection, but it is important to understand that there are a couple of things. One, you need to identify the right kind of data. Two, once you identify the data, you need to process it carefully, build it with a lot of integrity before it's being fed to a machine learning system. Three, you need to work in tandem or in collaboration with your in-house teams. It includes your developers, your database administrators, your QAs, and your data sciences team in order to build an effective artificial intelligence system that can help you in the defect detection process. So with these three thoughts, I would like to wrap up today's webinar. I believe we have covered as much as we can, and I hope we have provided an overview of where artificial intelligence can make a difference to defect detection. And with that being said, I would like to thank you all for your time today. And I would pass this over to Kirti, who can put forth any questions that you have raised with Kirti in the chat window. Thank you so much.
Yes, Vasu, thank you. We have a few questions coming in from the attendees. I'm reading out
Sure.
the first one. What kind of skills do testers need for machine learning?
I think I partially answered this. Your testers don't need any skills, right? Instead, it's not the right thing to train testers to it's not the right thing to train your testers with any skills. Your testers are already skilled. They come with an analytical thinking mind. They come with a different approach to looking at your product or your application and things like that. And if they are automation testers, I believe they already have the coding knowledge like a JavaScript or Java, where they are trying to use it to build their automated scripts and anything. I don't think it's fair to ask them to train on machine learning or anything. I don't think that's going to help also. Instead, they need to look at, or they need to work with data scientists and say, hey, we found this production issue a few days back. I need your help in in making a prediction in terms of what test cases would you recommend in order to test this if this happens in the future? Or can you look at my test pack and say, if there are test cases that are available today to test this? So what instead of looking at skills to train them, a good way to look at this is, can testers and data scientists collaborate to build an ideal regression testing pack, or a test pack basically, that would have the ideal set of user experience test cases that the tester would feel confident to test. So instead of having a lot of, I found a typo, this box got moved, this color is not good. I'm not saying those are bad issues, but instead of writing them as test cases and executing them, you can try to make your testers more effective. You can probably try and see how effective your testers are doing today, and if they are able to write and if they're able to execute effective test cases, then your production defects should go down. And that's the way to measure their productivity, and that's the way to measure their caliber. And that is where data sciences team and the testers can work together and make that happen. Actually, the objective is not to see how to skill my testers to do machine learning. The objective is to see, with more and more features getting added, how do I bring down my production issues? And to do that, how can my testers collaborate with data sciences? How can they create better test cases? How can they create more user experience test cases and things like that? And I think that's their fundamental job, and they should not be worried about learning data sciences or Python or R in order to create machine learning. I don't think that's the objective. Thank you.
Yeah, I think that helps. The next one is what technologies can we use for building machine learning model?
There are different technologies, but I think the most popular today is Python and R, which are used for building machine learning systems. Again, this is not something the tester needs to learn unless and until the project demands it. But the data scientist teams that are building these models typically rely on Python or R to build them. And there is some level of statistical analysis also involved, which means that you cannot onboard people with statistical knowledge to do that. So the data scientist team is where most of that comes in, and maybe programmers can help in using Python R to convert the statistical models that the data scientists give as programs, actually, that can which are nothing but the models itself. So again, going back to the question, the technologies can be Python and R.
Yes, thanks, Vasu. And the last one for the today's session we have, can we build AI in continuous integration?
I think those are two different concepts actually. Continuous integration is a discipline. Continuous integration is the act of doing code integration repeatedly, because integration of code is a huge challenge from early days. And when integration happens, there are conflicts when code merge happens, and conflicts can result in issues. Leading to time delays, and when you want to make it to production, then people say that it's going to take a long time to make a code merge. So in order to avoid that is where continuous integration came in actually, so that every day, every single day, there is a code merge that happens across the developers who are working in different parts of the world and all that. And the bottom line is code is always up to date. Any code line issues, any conflicts that arise will have to be resolved, and the code needs to be up to date. That's continuous integration. It has got nothing to do with artificial intelligence. Maybe if you are making a recommendation of test cases using artificial intelligence, those test cases can be put as an automated test suite, and they can run in a continuous testing mode. That is what I see actually. But I don't think artificial intelligence has anything to do with its application on continuous integration. I think they are totally disconnected topics.
Yeah, that is all, Vasu. Thank you.
Excellent. Thank you so much to all the attendees for taking the time to join us today. We'll be happy to address any other questions that you have. Please shoot us an email. Please visit our website. And as Kirti said in the beginning, the recording for this webinar should go live in 48 to 24 to 48 hours. Look forward to it. And thank you so much for your time today. Thank you.
Thank you.